You're welcome to Dynamic Educational Hub channel, your answer to the very question. This is your first time of coming across my channel. Subscribe to my channel and click on the notification icon to get more of my video when I release it. What are we learning in today's video? We are learning cofactor and adjoint of matrix. In this video, we are going to look at the meaning of cofactor of 2x2 matrix, solve example on 2x2 square matrix, and then we talk about cofactor of 3x3 matrix with example, then adjoint of matrix. If you haven't watched my previous video on minor, kindly watch it so you will not be lost in this video. Let's start. What is cofactor? Now this is the minor of all the entries of matrix with their positional sign. Mark that word, positional sign. Positional sign for each matrix is known by adding the row and column for each spot in a matrix, that is I plus J. How do you know the positional sign for an entries and elements? You add the respective row and column of the element together. Yes. If the value is even, the sign is positive, and if the value is odd, the sign is negative. Cofactor is just like minor. The only difference is that you want to consider this position, either that position is positive or that position is negative. And let's have this 2x2 square matrix. For A11, the position it occupies is the first row, first column. That is why we have 1, 1, 1 plus 1. A12, we have 1 plus 2. A21, we have 2 plus 1. A22, we have 2 plus 2. And if you solve that, we are going to have 2, 3, 3, 2. 2, 3, 3, 2. What does that imply? We have 2 is plus. Why is it plus? Why is it positive? It is positive because it is even. 3 is odd, negative. 3 is odd, negative. 2 is positive, plus. Now for 2x2 order matrix, if A is this, how do we now go ahead and find the cofactor? It's quite simple. The first thing is to find the minor. Minus of A, the matrix we're talking about, this matrix is going to be this. And then we know the usual method, we swap the diagonals. We have swapped it. That is the minor. The next thing is to find the cofactor. Consider the sign. Let's consider the sign. Then cofactors of A is going to be plus A22 because this spot is plus, it's positive. Just don't get yourself confused. Positive means that the sign still remains the same if it is negative that is there before. And the positional sign is plus, is positive. That the sign of that is still going to be the same thing. If it is plus, plus doesn't change sign. Now for negative, it's going to change sign. What did I mean? This one is plus initially. When we consider the sign, it's still plus, plus. This one is plus initially. When we consider the sign, because minus is there, it becomes minus. The same thing with this one, minus. The same thing with this one, plus. That is factor. How to find cofactor? Just finding minor and considering the position. For example, if A is this, now let's look at a perfect example. We have a number now. If A is this, how do we find the cofactor? It's quite simple. The first thing is, let's find the minor. We swap the diagonal. This are the minor. This is the minor of A. Now the next thing is to consider the positional sign to find the cofactor. This is the minor of A. Then the cofactor of A is going to be this, obviously. We've considered the sign. What is the sign? Plus. Plus for anything that is occupying this position. You add plus to it. Plus times minus, minus. You still maintain the sign -4. Minus for this one. But the value that is here is -1. When you put minus here, it becomes +1, 1. minus for this one. Initially it is 3, now it is now minus 3. This one is plus. Initially it's 5, it's still what? 5. That is cofactor of 2 by 2. And let's quickly look at cofactor of 3 by 3. To find the cofactor of 3 by 3, the first thing we need to do is let's calculate the positional value in order to know the cofactor. It's very simple. This one is 1, 1. You don't need to do all this. I'm just giving you the background. Just know that you are for 2 by 2 is going to be plus, minus, minus, plus. Like that. For 3 by 3 is going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. How did they get it? This is what I'm explaining. Now for this one, we have 1 plus 1. This one 1 plus 2. This one 1 plus 3. This one 2 plus 1. 2 plus 2. 2 plus 3. The next one is 3 plus 1. 3 plus 2. And 3 plus 3. This one is going to be 2, 4, 2, 3, 4, 3, 4, 5, 4, 5, 6. And let's consider these numbers. We can see that they are even. This one is even, odd, even, odd, even, odd, even, odd, even. When you change that to sign, plus, minus, plus, minus, plus, minus, plus, minus, plus. It's as simple as that. You consider this sign after you have done your minor. Why is this one even? That is what I'm showing you. Now just know this plus, minus, and minus, plus, minus, plus, minus, plus. If minor of matrix 3 by 3 is given as this, what will now be the cofactor? Let's consider the sign. Cofactor is going to be plus this, minus this, plus this, minus this, plus this, minus this, plus this, minus this, plus this. For 4 by 4 matrix, the stats is still the same method. You have plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. That is what we have here. Okay, have here for 4 by 4. What is adjoint of a matrix? Adjoint is actually simple. It is a transpose of cofactor of matrix. Transpose of cofactor of matrix gives adjoint of that matrix. Adjoint is denoted by ADJ. That is the meaning of adjoint. For example, adjoint of A is ADJA. If A is a square matrix of order I multiplied by I, adjoint A is going to be transpose of cofactor of A. The transpose of cofactor of A. For example, find the adjoint of this. If we want to find the adjoint of this matrix, let's see how to find the adjoint. The first thing is you find your minor first. The minor will be, as usual, the minor is just swapping. Swap this. These are the minors. And the next thing is to find the cofactor. To find the cofactor, this is what you are going to do. Consider the positional sign. For this 2 by 2, you have this. So just put the sign there. Instead of having 1, you are going to have minus 1. Instead of having 9, you are going to have minus 9. The adjoint will be. Now let's now find the adjoint. This is the cofactor here. To find the adjoint, you need to do transpose. They are simple to find. The first thing is minor, after minor, cofactor, after cofactor, adjoint. What is adjoint? Whatever cofactor you get, you transpose it. Let's transpose it. If you haven't watched my previous video, go and watch it. I've explained minor, cofactor, I've explained cofactor, transpose, determinants. This is the transpose here, just transposing it. You change the row to column. This is the row, you just write it like this. You write this one like this. Again, you write this, like this. And you write this way. Summary: adjoint of 2 by 2 matrix. Let's say you have this. You want to find the adjoint. The first step, there is a short method in which you can use to find adjoint. That is what I want to show you. To find adjoint, what you just need is you swap. The first step is to swap one diagonal. Just one diagonal. Just swap them. After that, the other diagonal, you put negative sign to it. Put negative, negative. Which means if you have A, B, C, D as a matrix, you want to find the adjoint. Just swapping the left diagonal like this, you swap it. After that, you put the other diagonal, you put negative, negative. You change the sign. So that is what we have here. That is how to find adjoint of 2. For 3 by 3 matrix, to find adjoint, let's say you have this. To find the adjoint, you must find the minor first. After minor, the next thing is to consider the positional sign from cofactor. After positional sign, then you are going to have your transpose. Find your adjoint. Let's transpose this guy. Transpose it. You have it that way. You have it that way. You have it that way. That is how to find. This is a perfect example which we are going to solve. We are going to solve. Let's solve this example, which is if B is this matrix. If B is this matrix, find I minor of B, I cofactor of B, I adjoint of B. To solve that, we have our matrix here. Then the minus is going to be this. I've solved this same question in my previous video on minor. I'm going to walk you through on how to solve this if you haven't watched that video, but kindly go and watch the previous video on minor. Going to be our minor. To find those minor, let's start deleting and finding the first one. We delete the first row, the second, the first row, the first column. By 1, that's 3. Minus 3 times 4, that's minus 12. Because of this minus, it becomes plus 12. 3 plus 12, 15. And now minor has changed to 15. That is how to find the minor. The first question. Okay. This is the first question which we have solved. The second question, it asks us to find a cofactor. And what is cofactor? We are considering the positional sign. So we have plus, minus, plus. What this implies is that whatever element that is here, the sign will not change because it is positive. This one, it won't change. If it is negative initially, it will still be negative. If it is positive, it will still be positive. So we have no business with this, and the one at the middle. The only one, those one that we have business with is the one with minus. Minus simply means we find the additive
inverse. We find their additive inverse. Any element here, you just change the sign, find their additive inverse. Any element here, you find the additive inverse. Any element here, you find the additive inverse. Any element here, you find the additive inverse. Additive inverse simply means you change the sign. If it is plus before, it becomes minus. If it is minus before, it becomes plus. Obviously, this is going to be our answer. Let's check. This one is 9 here before, it's also 9. This one is minus 8 here, it's also minus 8. Don't forget, plus, plus. This one is minus 2, it's also minus 2, plus. This one is 15 plus 15, we have plus here, it's also plus 15 here. Now let's see. For those one that carry negative sign minus, this one is 44 initially plus. Find the reciprocal, the additive inverse, it becomes minus 44, minus 16 indeed. The same thing with this one, minus 27. You find the additive inverse, it becomes plus 27. If you put minus with it, it becomes plus 27. This guy. Then this one is minus 23 before, because the position it is occupying is carrying minus. You are going to add minus with it, so it becomes plus 23. The sign has changed. Lastly, to this one, 24, it becomes minus 24. So with that concept, you can easily find the cofactor without stressing yourself, because some students get confused with this sign, and because a number, an element, the minor is carrying negative before, and the position is occupying is negative as well, they will just leave it as negative. No, we will miss the answer. If you're writing down, they will still put the same thing that you have done in your option, and then you will choose correct option, and you choose the wrong option. The last one, let's find the adjoint. To find the adjoint, you are using your cofactor. Just transpose it. This is how to transpose. You change the row to colon, or you change the colon to row, and that is going to be our transpose. If you haven't watched my previous video on transpose, determinants, minor, kindly go and watch those videos. And properties of addition, multiplication operation in matrix. Kindly go and watch the video. You can see that it's quite simple to find adjoints. In a question, you can be asked to find adjoints. To find adjoint, you just find the minor first, then you go about finding the cofactor. Then you can transpose the factor to find adjoint. Here is a practice exercise for you. Find the cofactor of the matrix above. You find the cofactor and also find the adjoint. After solving this question, comment in the comment section if you actually try solving it. If you solve it, comment it in the comment section. If you have watched my video and you haven't subscribed, kindly subscribe to my channel in order to get more of my videos. Click on the notification icon to get notified when I release new video. My next video is going to be on inverse of matrix and proof of inverse of matrix. Till then, bye for now, and thanks for watching my video. Stay blessed.